right, guys, let's hit this review. Number 1 through 5, I'll say find the exact value of the trig function at the given real number. First one says sine 4 pi over 3. Don't forget the reference angle is just pi over 3. So I'm thinking, what is sine pi over 3? You should know that's square root of 3 over 2. 4 pi over 3 is 4/3 pi. It's in quadrant 3. Everything is negative, so it's negative square root of 3 over 2. Second one, cosine 11 pi over 6. Reference angle is pi over 6. You have to know cosine pi over 6 is square root of 3 over 2. Because the top is double the bottom minus 1, that's quadrant 4. Cosine is positive in quadrant 4. We are done. All right, cosecant negative pi over 6. I'm really going to do sine of pi over 6 to get my value, which is 1/2, by the way. But because it's cosecant, I'm going to flip to 1/2 to 2. Negative pi over 6 is in quadrant 4. Sine is negative in quadrant 4, so it is negative 2. Number 4, tangent 2 pi over 3. I'm really going to do tangent pi over 3. Because it has 1/3, the answer has 1/3. 2/3 pi is in quadrant 2. Tangent's negative in quadrant 2 because it's y divided by x, and y and x have different signs in quadrant 2. Cosine negative pi, I'm thinking about cosine pi, which is -1. And by the way, pi and negative pi are at the exact same spot. It's -1. Number 6, find sine, cosine, and tangent of that terminal point. The good news is sine is the y. All right, so we're just going to say sine is y. Boom. Cosine is x. I don't know how you missed this. And tangent is y over x. And if I put the y over x, what's going to happen is the denominator is going to cancel. So I'm just going to get 9 over 40. Number 7, which quadrant would the terminal point lie if sine is negative? That's y is negative, and cosine, which is x, is positive. So cosine is positive on the right-hand side. Y is negative on the bottom of the coordinate planes, which means if you go right and down, that's quadrant 4. Roman numerals, please. Number 8, find the area of the triangle. This is the Heron's formula we did last week. You need to find S, that should be area, sorry. You need to find S first, though. S is a semi-perimeter, so add up all the sides and cut it in half. 3 plus 5 is 8. 8 plus 6 is 14. So the semi-perimeter then is 7. So I'm going to do 7, and then do 7 minus each side. 7 minus 3, 7 minus 5, 7 minus 6. And all I'm going to do is punch that in my calc. And I'm getting 7.48. Should be meters squared. That's a 7, by the way. Looks like I combined the decimal point. 7.48 meters squared. All right, 9, 10, 11 are basically gimmes. These ought to be 3 freebies for you guys. It says find the reference angle. Remember with radians, if it's a 3, 4, or 2 on the bottom, or 6, you can just drop the top. So I'm going to drop the top. But however, then we run to 11, which is no longer a 3, 4, or 6. Okay, so you got to think about this one a second. -5 pi over 8. First of all, that's pi over there, or negative pi. If I'm going this way and I go -5/8 pi, other way to pi, how far away am I from the x-axis? And the answer is I'm 3 pi over 8 away. Remember, reference angles must be positive, must be acute. How far are you from the x-axis? All right, find the terminal point determined by t. Okay, I'm really thinking pi over 4 here. If it's pi over 4, that's a square root of 2 over 2. Both of them are square root of 2 over 2. The question is, what quadrant is 5/4 pi in? It's in the third, so everything's negative. Number 13, -11 pi over 6. I'm thinking pi over 6. At pi over 6, the x is square root of 3 over 2. The y is 1/2. Now I got to think about the quadrant. If you go -11 pi over 6, if it was positive 11 pi over 6, it'd be quadrant 4 because it'd be double the bottom minus 1. So if you go backwards to the other, I'm saying quadrant 4, it's really quadrant 1. Everything's positive. That's in quadrant 1. 14, that's really -2 and 1/3 pi, which means you would go all the way around the circle -1 time and then down a third. So I'm thinking of pi over 3, first of all. In pi over 3, I have a 1/2 and a square root of 3 over 2. I've already shown you it's in quadrant 4, which means x is positive, y is negative. 15, show that this is on the unit circle. Now, saying it is on the unit circle, you got to prove it. And if it's on the unit circle, that means you should be able to square both of these, add them up, and get 1. So if I square 7/25, I get, even if it's negative, if you square negative, it becomes positive. I get 49 over 625. If I square this one, also 625 on the bottom, 24 squared. Let me punch it. I think it's 576, yes. And what happens is, what that shows me is I get 625 over 625, which equals 1. 1 is the unit, all right, of the unit circle. 16, find the length of an arc. The subtends a central angle of 50 degrees and a radius of 3. I'm using this formula. This blast from the past a little bit. Remember, you can only use this formula for radians. They gave me degrees. So my first step, even though this is not going to be the answer, I'm going to change this to radians. This is how we do that. So if I reduce that, really the zeros just cancel. So I get 5 pi over 18. I'm looking for the arc, which is S. The radius it says is 3. I'm going to cross multiply right here, make that 15 pi and 18s. If I divide by 18, I get 15 pi over 18. Reduce that, and you get 5 pi over 6. And you can punch it in your calculator if you want to. And actually, that should be meters right there. 17, find the average rate of change. We've done this a lot. We're still struggling on this some, though. So let's knock it out this time. First of all, this is really just slope, remember. These are my x's. These y minus y breaks minus x. So I'm going to put this x first minus my second x. So my denominator is going to be h. All right, now to get your y's, you're going to plug in the 3 plus h for the x 2 times. Okay, so that's what it looks like. This first one, I'm going to square, multiply, double square. So I'm going to get 9 plus 6h plus h squared. And my second term is just going to be minus 18. Oops. I'm missing something. Oh, it's minus. That should be a minus minus. That should be a plus 18. I hope that makes sense. That's a negative. I forgot that negative right there. It's always minus here, then it's negative 2 times that. So I hope that made a little bit of sense. Sorry about that. Let's work out the numerator here. I'm going to distribute the negative 2. I get negative 18 minus 12h minus 2h squared. I got a plus 18 also. So what happens is my 18s are gone. And what I'm going to do is, since everything that's left, these 3 terms right here all have h's, I'm just going to take an h out, make that a negative 12, and make that a minus 2h. And we're done. So number 18, 19. These are just shift, like what's going on. And this one's got a negative inside, which means it reflects across the y-axis. That's a long time ago. And that minus 4 outside shifts down 4. That's a down right there, down arrow. All right, number 19's got a bunch of stuff. 19, the negative's outside, so it reflects across the x. That's the first thing. I usually go left to right when I do these, which is what I'm doing right now. The 2 is a vertical stretch by 2. And the plus 7 is a shift left 7. Opposite what you think. All right, almost there. Hang in. This one, we got to multiply everything by the LCD. If I factor that denominator, it's x plus 2x minus 2, which actually gives me the LCD. I'm going to multiply every term by the x plus 2x minus 2. One other thing while I'm thinking about this is you probably should go ahead and write down what x cannot equal when you get done. Like there's no way I can get a positive or negative 2 for an answer because that will make the denominator 0. All right, this first term, the x minus 2 cancels. That leaves me an x and an x plus 2. On the second term, the x plus 2's cancel. That just leaves an x minus 2. I think I wrote that wrong up there. And the third term, everything cancels, so I just have 8. Okay, so if I distribute, and let's multiply this stuff out, I'm going to get x squared plus 2x plus x. I want to move this 8 over, make that minus 10. That's really x squared plus 3x minus 10. Factor that thing, get x plus 5, x minus 2. Ooh. So I get these two answers. X is negative 5 and 2, but don't forget what we said earlier. X can equal 2 or negative 2, so that answer's out. It's extraneous. It's just negative 5. Last two. Been a while since we've done one of these. 2 ways to do this, remember? I think what we decided last time was the easiest way, just to multiply the whole top and the whole bottom by what the LCD is, which is x and 2. If I do the first term times 2x, the x's cancel. I'll use 1 times 2, which is 2. If I do the second term, the 2's cancel. It leaves 1 times x, which is x. In my denominator, don't forget 2x times all that stuff. Matter of fact, if you want to, you can do this, or you can multiply it out. The reason I left it like that is because I'm looking at the numerator and denominator, and those are opposites, guys. You can cancel opposites, remember, if you put a negative 1, which leaves me a negative 1 on the top, a 2x on the bottom, and you're done. So one more. Graph piecewise. Okay, well, we've done this quite a bit. Let me darken the axis a little bit so you can tell there's my x-axis right there. The y-axis. Okay, so take the negative 1, just plug it in there. That's a line, by the way. It only takes 2 points. If I plug negative 1 in, I get positive 1, which is right here. I'm filling in the circle because there's an equal sign. And because it says go less than -1, I'm going to plug in -2 next. And if I plug in -2, I get 0. So I'm going to connect the dots. La, la, la. And there's the first piece. The second piece is a parabola. And remember, when we do parabolas, we do a few more points than just 2 to get the shape of the parabola. Start off by plugging in -1. -1 squared is 1. That point's already there. It would be open if it wasn't there, but because it's already closed, it's closed. I'm going to keep going to the right because it says greater than -1. If I plug in 0 in there, 0 squared is 0. 1 squared is 1. 2 squared is 4. That's enough. It goes forever because it just says greater than -1, so that means I'm going to put an arrow there. And guys, that's it. Hope that helps. That's 22 problems. That's quite a bit. They're fast, though, so I don't think you'll have trouble finishing. But please make sure you know the stuff. I'll be in my classroom tomorrow if you need me. Come see me, please. See you then.